Welcome. How you guys all doing? It's 8:30 in the morning. It's a good time to be up. So, welcome, and my name is Brian Johnson, and I'm joined here with Dhananjay Mahajan from Microsoft, and we're going to talk about SDN and what the Intel and Microsoft vision are and some of the new products and technologies that we're developing in order to help bring this vision to market. Objectives. What's changing in networking around the cloud? Why is network virtualization important? And then what our strategies are. Over the last 10 plus years, the data center has been going through a lot of innovations and changing. Start out with moving to Intel-based servers, dedicating servers for different workloads. A lot of those servers only ran one workload. So server virtualization started rolling out. Took quite a while to get people comfortable with virtualizing the servers, but now even our mission-critical server workloads are being virtualized. Next step was taking those virtual servers and extending them out maybe into the cloud, or to have shared resources instead of having that same paradigm of these are my 5 virtual server hosts, those are mine. Now there's a rack, I don't really care where they live as long as I can meet my SLA. So a lot of changes in the architectures that go to support that, but also the mindset and the paradigms that we have around how we look at the data center and how that technology is impacting the way we do things, especially on the networking side. The growth that we are seeing is phenomenal. In fact, we even have more up-to-date numbers on this that are even larger. More than 3 billion connected devices. The amount of information is astounding. Now we're looking at it from a big data standpoint. How can we actually take advantage of all this data? But from a storage, networking, how do we get all that stuff to talk? How do we manage that? The increase in mobile and tablet and all the different connected devices is really causing a lot of changes in how IT has to handle and the policies that we have. The last item there on the growth, the 2x or $27 billion in additional power costs. That was something actually that Intel IT was projecting. An additional 30 gigawatts of power was what we're looking at in our data centers from 2011 to 2015. That's enough to power 10 million homes. So there's a lot to this on the growth side and increasing all the challenges from the IT department. We don't get a lot more resources. We have to do more things, have more capacity, and look at how to avoid lock-in in technologies. We have to really maintain that open, flexible type of standard interaction. A lot of the research shows that companies are moving to some sort of cloud architecture in order to address all these challenges. 40% plan on moving to either a public cloud or a private cloud. 35% around the hybrid cloud, of combining the use of private and public cloud support. The example at the bottom there was some work that Intel IT did to move our data centers into a cloud, a private cloud environment. 2009 took roughly 90 days to provision a server. In 2011, as it shows, that was down to 45 minutes. Last week, I was meeting with some of the IT guys, and we were talking about what I was going to say here, and we were kind of reviewing this. What that slide doesn't talk about is it took 45 minutes to provision the server, but there was a 5-day SLA to configure the network for that server to talk. And that still is one of the big stumbling blocks that we have around even taking advantage of virtualization as a whole right now, is that there are other aspects of it. We can spin servers up quickly. Getting the rest of the network and connectivity is still a challenge, and we're going to look at that a little bit more. Some of the other barriers, risk aversion. Certain aspects of the different groups in the data center may have different levels of comfortability. A lot of the server guys, we weren't real thrilled about moving our physical servers into this virtual environment. We kind of got over that, and now we really enjoy virtualization and the freedom it gives us. We don't have to wait for that hardware to show up. We can spin servers up. Quality of service, also a big concern for people. How do you handle multiple tenants? I don't want a noisy neighbor on the same host as me. I don't want them on the same subnet taking up my bandwidth. How do you handle that? Technology maturity, when virtualization first started coming out, once again, we weren't real comfortable with it. It was all new. Scale, automation, standards. Standards around virtualization, network management, and networking are all in have a lot of flux right now. They're being defined, trying to address different aspects and different challenges. Now we're trying to put things together, and that's what we'll go into a little bit more detail on that. The cultural and organizational. I still face a lot of this in customer calls. People are asking me about how virtualization works in certain aspects on the server side, how they are challenged with their networking guys. I do a lot of talks around moving from 1 gig to 10 gig. A lot of networking groups are still holding back on moving to 10 gig environments. Cost of the switches, new paradigms. Well, you don't need that much bandwidth. Your VMs aren't taking up that much bandwidth. That's really not necessarily the case, and we'll talk about why you need some additional bandwidth on the network. And then overall, balancing out the whole platform and being able to scale that whole infrastructure. It's not just looking at one aspect. It's not just putting in fast servers or SSDs into your storage or 10 gig networking. It really has to be looked at as a whole system. And at Intel, we've really started looking at this multi-year roadmap or strategy of how to bring some of these technologies in, address some of the challenges as we move into this new deployment model of the cloud. From a server standpoint, obviously we get faster processors. Intel does that very well. But we also are looking at the chipsets. What other technologies can we put into the processors? Last year when we launched the Intel Xeon E5 2600 series processors, we moved the I/O into the processor itself. So now PCI Express the root complex is built into the processor. That allowed us to have direct access to the memory. So we have Intel Data Direct I/O technology, allows our network controllers to talk directly to the processor cache, reducing power, latency, and increasing our performance. We're able to go from about 150 gigs of network traffic up to over 250 with that type of technology. So we're not just looking at server processors to crunch numbers, but also how to increase the I/O capabilities of the platform. Storage, obviously bringing out SSDs, looking at new models of storage. Let's skip over networking for a second here. Security, building in the offloads and capabilities in with like Intel AES&I and different capabilities in the platform itself, and then working to figure out how to manage that all from an orchestration layer. The rest of the presentation will focus mostly on the networking side of things. Last year was a big year for 10 gig and for unified networking and virtualization. With 2012, brought in additional capabilities around iSCSI, FCOE, SMB, with the unified networking, allowing us to use common 10 gig infrastructure for that. Made big advances in the performance on the 10 gig in a virtual environment, bringing in other capabilities. And then this last year, bringing out top-of-rack switches, reference designs, and switch silicon to help move us into this SDN environment. And we'll go over a little bit more of that. With that, I want to bring up Hanjay.
Thanks. Thanks, Brian. Welcome, everyone. I'm Dhananjay Mahajan. I'm part of the Windows Server System Center Partner Engineering team. And my team's role is to help partners, and Intel is a long-time partner that we have. So thank you, everyone, for coming. And thank you, Intel, also for being a gold sponsor of this event. Today, I'm excited to talk to you about the enhancements we've made in Windows Server 2012 R2. And then we will dive into, I'll hand it back to Brian to talk in more detail about the enhancements that Intel has helped us in accelerating our platform, in getting more performance, scale, as well as functionality improvements in the networking aspects of our platform. So when we launched the TechEd conference, Brad Anderson went through Windows Server 2012 R2 and the key focus areas that we have for R2. We want to help take our customers' enterprise beyond virtualization. As customers are moving towards the cloud, it's not just virtualization, but helping them build a multi-tenant infrastructure that's flexible. We want to create pooling, make it very simple for you to pool servers, to pool storage, to virtualize the networks, so you can efficiently manage your infrastructure and maximize your availability, make it multi-tenant, be able to onboard tenants quickly. And all of these come from our learnings from running our own services such as Office 365, Bing, Azure, and we want to bring those benefits back to our customers. We want to make it possible to help you to have every app run on any cloud through an open, scalable, and flexible web platform. And we want to enable the modern work lifestyle of your information workers, where many of these workers are bringing in their own devices into the enterprise, and security, access to data anytime, anywhere, on any device is extremely important to your workers, to your knowledge workers. So thinking specifically about networking, what were some of the areas that we wanted to focus on for R2 and we brought out in terms of technology improvements? As Brian was pointing out, it has become very simple to provision a server. It takes 45 minutes. But provisioning a network takes an SLA of 5 days. So we want ability for our enterprise IT to deliver networking in a pooled, automated infrastructure that you can provision quickly, so that you can decouple from the physical and virtual and be able to automate a lot of your processes. Ensure that multiple tenants can be onboarded quickly. So you can move the VMs for each of the tenants across the network in a flexible fashion without having silos. Many of our customers require expanded capacity when so you can have burst capacity possible through the capabilities we are providing in 2012 R2. And all of this, as Brian was also pointing out, adds to the additional complexity of your network and network administration. And we want to reduce that complexity. So let's talk about software-defined networking, what Microsoft's view is. And I'll talk about the enhancements we have made in Windows Server 2012 R2, and we'll also talk about the enhancements we have made on storage with a focus on networking. As we talked about how networks are transforming, we have virtualized compute through the hypervisor, through Hyper-V. Now, many of our customers want to virtualize the network resources. So abstracting the physical and virtual networks becomes an important consideration. We want the ability to span the policies for configuring these networks, for automating, deploying applications on these networks, span across physical as well as virtual domains. And we want a seamless way to control traffic flow within your networks and shape your traffic as is needed so that you can deliver your quality of service, so you can deliver the SLAs that you have for your applications. The key tenets, as we went into designing the capabilities for network virtualization in Windows Server 2012 R2, were flexibility, control, and automation. And I'll go into a little bit of detail into that, but we want you to be able to deliver an end-to-end solution. We want to bring in innovation in our platform so you have a complete solution, but also bring in innovation that our partners such as Intel are bringing in, both in hardware and in software, to give you much more choice, much more capabilities, and reduce your CapEx and OpEx. And our platform is open, extensible, and standards-based. So you don't feel locked in. It's based on industry standards such as NVGRE. It's based on industry standards that we are pushing such as OMI. Flexibility. As I was talking about, you want the flexibility between the virtual and the physical network. And we want to help you virtualize your networks with an overlay on top of it that gives you multi-tenant isolation. Many of these tenants want to bring in their own IP address space, and there should be ability and flexibility in our platform for onboarding these tenants quickly. At the same time, maintaining secure access to their data and to their applications. We want to give you better control. So with an integrated control plane that goes across physical and virtual, you can have the same set of tools through System Center, Virtual Machine Manager to deploy and manage your network policy and be able to deliver the QoS and control the traffic. And all of this brings in a lot of reconfiguration and a lot of manual steps. For Azure, there are over 50,000 different actions that get taken every day. And instead of making it very manual and error-prone, we want the ability to automate these across your network with a consistent profile-based deployment for your SDN. This is realized through Windows Server 2012 and System Center 2012 SP1, but also further enhanced with Windows Server 2012 R2 and System Center 2012 R2. So let's dive a little bit into storage. All of you here who are using Windows file servers are very familiar with SMB. And we have taken SMB to the next stage, SMB 3.0, to give you more capabilities so you can bring in the existing knowledge and existing expertise that you have into the new cloud world without having to rip and relearn everything and deploy new technologies. With file-based storage of SMB, you can pool these through clustered shared volumes so you can have a single file system namespace that can then be exposed as a single logical server to not just your file servers, not just your files and Office app documents, but also now to Hyper-V and your VMs. And this is not to just store libraries of VMs, but you can run VMs on these shared single logical servers. And then through SMB, you can run your SQL capacity workloads all on top of SMB. So it takes away the complexity if you wish to set up SANs. We have capabilities to work with SANs and iSCSI and Fiber Channel, but we also have similar capabilities that you can realize through SMB. And with SMB transparent failover, even if one node is lost, you can still have the high availability that you have promised your customers. And all of this with taking advantage of the existing infrastructure and reducing the application downtime. Whether you have SANs or whether you have storage spaces or you want to pool your storage, all of these capabilities are available to you for running your VMs and running your mission-critical workloads. With greater uptime, with capabilities like we've added with SMB multi-channel, SMB direct, and SMB transparent failover. Whether you're doing it through RAID, through SANs, or storage spaces. Plus, we've worked with Intel in making more enhancements that give you faster I/O and better performance improvements, as well as better scale. And let me hand it back to Brian so he can go through some of the enhancements Intel has done in this area.
Thank you. So why are we talking about storage in a networking group? One, storage is highly required for virtual environments, and shared storage is also required, which means that you have to use networking to pull this all together and have the communication. The aspects of using SMB and actually being able to get similar performance that you would get on a local disk over the network is actually pretty challenging. So just like when we came out with 1 gig adapters, it was a challenge to hit 1 gig speeds. The CPUs didn't have enough power to actually be able to process enough networking to hit the speed, so we built in technologies into our controllers to help address that, built it into the platform. The platform eventually caught up, and we didn't need those anymore. 10 gig, same sort of issue, and in order to get full line rate over 10 gig and get that local storage type speeds, we've worked with Microsoft in order to bring in additional capabilities and take advantage of some of the networking assists that we have available on the platform now. One of those is multi-channel. A single CPU core may not be able to hit full line rate on 10 gig. By using technologies like RSS, we're able to span that traffic over multiple cores and hit full line rate, in fact, hit full line rate across multiple different adapters. RSS has been around for a long time, and we use it in a lot of different aspects, and now it's being used for SMB in order to get us that line rate speed. One of the other big aspects for the networking side in 2012 was the introduction of LBFO. So actual native teaming that is available in the Windows operating system. And why that was important, we used to build our own teaming. We had ProSet, and as part of our drivers, we allowed us to do the teaming in 2008 R2 and previous generations. Now with LBFO, we're able to work with Microsoft to optimize a stack across multiple different vendors and have common capabilities across all of the NICs. And one of these is adding additional capabilities as far as being able to team the SMB protocol. And so now combining the teaming capabilities with multi-channel, we're able to get multiple threads going on each one of the adapters. So instead of just having a single connection with a single CPU core behind it, now we can expand that out across multiple cores and multiple sessions per port that are using SMB in the multi-channel. So this gives us huge scalability opportunities with the storage and engages the more of the platform aspects. You can see how we can scale it using 1, 2, 3, and 4 different 10 gig ports, and how it just keeps adding additional capabilities in. So similarly, when we move from that physical environment to server virtualization, we had similar challenges that I just described with the SMB of using a single core to handle all the VM traffic in a server, being able to process it. One of the aspects that virtualization brought in is that top-of-rack switch that we used to plug all of our physical servers into is now inside of the hypervisor. We have to have that same level of performance, same kind of capability that we had in that top-of-rack switch, now in the hypervisor vSwitch. So we built in some technologies, and in 2012, and this is even expanded more with 2012 R2, a lot of functionality that we saw in those top-of-rack switches is now being brought into the virtual switch, and we have technologies in our network controllers to help support the performance that is required on those switches. When we do testing of VMs and the performance of how much bandwidth can we get out of the VMs, when we're going from VM to VM inside of a single host, so when it's communicating over that vSwitch, we're able to see upwards of 60, 70 gigs of bandwidth being utilized between those VMs inside of the host. So the vSwitches have a lot of performance capabilities, so we can bring in two VMs that are onto the same host and actually get better performance than we could actually running it over the physical network now. Bringing data in and out of that switch, just like we were talking about with SMB, requires us to do utilize more cores and do that in a dynamic fashion, because if we start separating out all the traffic into its own core, we can actually reduce the performance of the platform because of all the additional interrupts for network traffic. So we use technology that Intel has provided, VMDQ, to support dynamic virtual machine queues, VMQ, same letters, just switched around a little bit. And that allows us to have that same type of RSS capability that, that I showed you with SMB, but in a virtual environment. So now virtual machines can be assigned their own queues. We can align the core and the traffic that the VM is using, and that makes it a lot more efficient. We don't have to copy data into the parent partition in order to transfer it up into the VM. So we can make that much more efficient, but we can also do that in a dynamic manner where we can consolidate traffic into a single core to help reduce the overall interrupts in the system. And then when there's a certain level of traffic, we can expand it out and they get their own core and we can pass the data up more effectively. That still may not be able to meet the requirements or the performance requirements of some VMs, specifically around network functions. So like load balancers and firewalls and analyzers. Those have a tendency to be more, have a higher percentage of small packets. So moving millions of packets is still a challenge to do in software. We're doing some innovation and work on that, and every generation we get better and better at it in the software switches. But we bring in a technology called SRILV, which allows us to have a direct assignment from the VM into the hardware, into the network controller. And that bypasses the Hyper-V switch and removes some of the potential latency and overhead that's associated with that. As you see on the chart here, comparing SRILV to VMDQ, so the virtual switch, performance on the large packets is pretty similar, and actually I'd say the CPU difference is minimal overall. Where you see the bigger difference is down on the small packet side, down there at 64 bytes and up at 512 and 1K. You can see that there is a lot more performance on that direct assignment, so that using SRILV. That does come at a cost to flexibility. While we still can do live migration of that VM, you are bypassing the hypervisor and all of the quality of service and the functions that I showed you in the Hyper-V switch. That's what SRILV is intended to do, which is to bypass it. But you really need to make a decision which is more important, the features or that additional speed in that area. So if you do need a little bit lower latency or higher small packet performance, this is an option. But it's not something that you want to go out and run SRILV on all of your VMs. And it's kind of a misconception, and why I spent a little bit of time on this is there are reasons to do offloads, and that's basically what this is doing. It's offloading the virtual switch. But it really needs to be weighed out with what you're offloading, or what you're avoiding. So the overhead of the virtual switch, which in most cases is minimal and outweighs any kind of additional performance that you may see on that VM in most cases. So just wanted to make sure that there's an understanding on that, and go into some of the additional challenges that we have on the networking side. So traditional networking. The way we do things and have been doing things really hasn't changed a lot as we moved into that virtual environment, the virtual servers. We're still plugging servers in. A lot of, I still have a lot of questions from the virtualization and server administrators. My networking guys only give me one VLAN. They won't trunk, they won't give me additional bandwidth. They say my virtual machines don't need it. Well, the virtual machine aspect may be minimal traffic compared to all the other stuff that's going on. So that's one thing. The additional operational cost and complexity that goes along with managing software switches, hardware switches that don't talk, that are in completely different environments, that may have different managers, and won't, some of the traffic couldn't be seen as it moved into a virtual environment. I mentioned the VMs talking to each other on the VM, on a virtual switch. That traffic used to just disappear off of the network because we couldn't see it going from VM to VM inside the virtual switch. So we had VMs that would get migrated onto the same host. Alerts would go off that the network traffic disappeared. Get called in. Yep, it's still working, but that traffic wasn't being monitored. And a lot of that management and a lot of that visibility has changed now as the Hyper-V virtual switch has provided that additional capability and visibility into the environment. Spent some time talking about the server and network provisioning. That's still a big issue. I personally have to get my server or my networking guy in my lab to set up certain switches. Even in my lab environment, I have to wait for him. Fortunately, he's here traveling with me, and I don't have anything going on at the back at the lab right now, so I don't have to worry that he's traveling and I need to get something done and trying to manage that out. Controlling the flow in the data center is also one thing that is really being challenged. As we start moving into other aspects, which we'll go into, the traffic may just look like one connection coming out of the server. It may not be visible to see all of the different VM traffic that is actually just coming from a single IP address. So, what's the next step after server virtualization? Network virtualization. Offering that same type of capability that we have in a virtual server environment, but be able to do that in the network and provide that same level of abstraction that we've been able to build up over the last 10 years. And this is the little animation and build on putting in a server. When I say that it takes 5 days for that SLA, in order for that server to talk to the other green servers, you actually have to get the networking guy, which he doesn't want to show up right now. There we go. So that's the problem. It takes time. I didn't intend for that, but it takes time. That's a pretty simple configuration. Top of rack, add another VLAN. But now, if we have a rack that's in a different part, you may have multiple different network administrators that need to be involved in order to coordinate the different VLANs. That all has to be worked out, make sure that there isn't any conflict if you're moving from one part of the data center to another, or extending out your data center into a remote office or up into the cloud. So with Hyper-V network virtualization, there are multiple different categories or benefits to the different groups involved. From a workload owner, I can keep my own IP addresses, everything that I've set up, I can continue to use that and I don't have to worry about coordinating with other workload owners. I can bring in my own IP addresses, my own settings and policies, and maintain that. From an enterprise perspective, I can now expand out and use a hybrid cloud environment. So I can go out to the public cloud and maintain that same IP scheme and add additional capabilities, or put the workload out onto the cloud. Workloads that I don't need to host internally anymore. From the hosters, providing that capability to the workload owners and the enterprise. Being able to offer, bring your own IP address, not say, well, if you want to use that, you have to go to these IP addresses. That is a huge hassle. And that's one of the things that we've been working on with the Intel IT staff, is how do we build in all that flexibility into our environment. And then that combination of private and public cloud, that hybrid model, really being able to take advantage of it and move workloads and put them out into the cloud, maybe because we need additional capabilities or we don't want to host it anymore. Or bring the workload closer to the end user that's using it, instead of having to go back to the remote back into the data center, provide it in the cloud. May be a more effective way than utilizing our resources. So a quick overview on how MVGRE can provide this type of capability. So we have two different tenants, blue and red. You may have seen this scenario before. They both have the same IP addresses sitting on the same server. Normally, you wouldn't be able to do that even on the same network, let alone the same server. But, oops. If the blue VM wants to talk to the other blue VM, since it has the same IP address that that red VM has, we use network virtualization to provide the functionality, and we encapsulate that traffic onto its own virtual segment ID and use what we refer to as the provider address in order to bring that across the network. So now when the red VM communicates using that same IP address, it gets encapsulated but with a different VSID, goes over the provider address and network, and then goes back down and gets decapsulated on the server in the Hyper-V switch, and then gets routed to the appropriate red VM. So that's a way of using the same infrastructure to provide virtualized networks, virtualized environments, just like we did for servers. But now this isn't just unique to a single server. This is something that we can do across multiple different servers and provide functionality that would allow a network or allow a server administrator to add a VM to the environment. And because that provider network is already defined, the traffic just goes right over that without having to get the networking staff involved. So it makes it a lot easier to spin up that VM and gives us the flexibility that a cloud environment, multi-tenant environment needs. Now, when we talk about multi-tenant, it may not be multiple companies. Maybe sales, engineering, multiple different groups. Now we can create the shared resources and make them, in these pooled resources, as Dahanjay talked about, was where each group has their own pool of resources and it's on a shared infrastructure. It's a lot easier to manage. Although, doing this type of work manually can be a little challenging. If you look at all the data center policy list on the side, you have to map the customer address to the provider address, which assigns it to that VSID, and maintain that. So if VMs move from one host to another, your provider address actually changes. So you have to remap that customer address and the MAC address to the new provider address of the server that it sits on. Doing that manually is not realistic in a large environment. I can do it in a small environment, but we don't want to be having to do that type of work in a large environment. And fortunately, SCVMM allows you to manage that, and that's where those policies reside. And they get pushed out to the hosts, and that's where that management takes place. But if we really want to take advantage of the cloud, and so the slide says here, why is SDN important to the cloud? Software-defined networking. We can do a lot of this stuff already, but what needs to change in order to make it better? And I want to look at the three attributes that SDN brings to the network. Decoupling of the data plane and control plane. So the data plane being what actually transports the data, and then you have your control plane, which controls all the policies and everything. We want to try to separate that out so you don't have a single place or multiple places where you have to go do that. On the top of rack switch, each switch you have to go control, or go set up each hypervisor individually, or each virtual switch individually, or the VMs individually. You want to centralize the management of that, including that top of rack switch, and then also controlling the flows in the network. So centralizing it, and then abstracting it like we did in server virtualization, separating that out from the physical hardware that it resides on. So be able to bring up that same type of environment that we did on the servers and how we manage those virtual machines. One of the examples that I use in describing this is the virtual machines. We can walk up to a Hyper-V host and set up a virtual machine. Get it up and running. Just do that locally. But do that for 10,000. You have to have some type of management. And we do that, right? We do that with SCVMM and other management tools. That's what SDN brings, is that those management tools. We can go set up individual network appliances, but that is too cumbersome in a large environment, especially in an environment that changes all the time. So I want to give an example outside of the computer world on this. One, property management. You are now a property manager. You have a rental house. You have an apartment complex and a hotel. It's kind of like playing Monopoly. How do you make money? How do you handle the management and simple thing of providing a key to each one of these different environments? Rental house, single tenant, single family. It's relatively easy, infrequent change. How do you make money? Long-term investment. Use that thing. You want to have low turnover. You don't want to constantly be having to put in new renters. I can probably manage that individually. An apartment. Multiple tenants. Occasional turnover. A little bit more complex to manage, though, because now I have shared areas. I've got private areas that I have to give keys to, and I got to maintain the security to make sure that everybody has access to their own places. The hotel environment. Frequent turnover. Many people, right? Daily, people are constantly coming in and out. a lot of shared areas, and I'm paying for the use of the facility. So if I pay to have club access or access to the pool, whatever, I have to provide that function to the staff. We don't have physical keys anymore to our rooms, right? This is all we get. And I can go up to the club room, boom, and I can get in. But as soon as my stay is over, this card doesn't work anymore. Turning over and maintaining the hotel takes huge staff and putting in a lot of systems and automation in order to be able to make money. Because keeping your expenses and your operating costs down is how you make money in a hotel environment. Well, it's easy. Switch this over to the computers and the data centers. Physical environment, just like a rental house, long term. We want to use that thing until it is no longer useful, basically until it stops working. Virtualization, you can manage it in small deployments. Hotel, it's more like a cloud. That is really why SDN and having this level of management is so important. Being able to span out, if I stay at the Marriott, I want to be able to use my Marriott, get my points, so when I go to another Marriott, it shows up with my name on the TV. It says, "Hi, welcome, Brian. Thanks for staying with us." I want to be able to do that kind of stuff, and that's really what we want to be able to do in that cloud environment as well. So SDN brings in programmability, automation, and control. This gives us that flexibility in the network, just like we would see in a hotel environment, which reduces CapEx and OpEx. This is going to take some time. I still remember having physical keys at hotels. It wasn't that long ago that was the case. So we're going to see this transition over time. It makes sense in large deployments. The investment makes sense. And we'll see that going into smaller deployments as the benefits start outweighing the costs. So from a switch hardware perspective, when we talk about decoupling the data plane and the control plane, there's an operating system that sits on each one of the switches. They are basically standalone and need to be controlled and managed basically locally. By moving to that SDN model, abstracting that control plane, moving it into a centralized area, running it off a network controller, and having the data plane on the switch being controlled from a central location. This allows us to streamline the different configurations and centralize the management of not only the policies on that switch, but also align them with the virtual machines and the environments and all these traffic flows that are going over the network. As we start using network virtualization, I mentioned that you have that provider address. That provider address is what all the traffic coming off of that server looks like on the network. So now you could have your virtual machines, you could have a couple dozen of them all talking over one IP address. And if the switches don't realize that that is actually a couple dozen different flows, then it may not be able to optimize the flows like it does today with each individual IP address coming off of each individual VM. So being able to look into those packets, into those flows, and be able to distribute them across the data center appropriately to watch for congestion and dynamically program those different switches to handle that different type of workload. That's really where the next step comes in. And that's similar. That's why I spent some time on dynamic VMQ. being able to know when to add additional cores and different queues for the VMs at the virtual switch level, that's similar to what we want to be able to do, but at the physical switch level, even when we're doing network virtualization. So one of the aspects that Intel is working on is part of this Intel Open Networking Platform, a switch reference design. We have switch silicon. We have a really solid CPU. And now we're building top-of-rack switches, or this reference design for these top-of-rack switches that can take and be used in this SDN environment. Using the power of the Xeon to run the operating system and building it up on standards allows us to have central control of the switches and provide the performance and the flexibility that we have in current top-of-rack switches. So one of the aspects of this is the switch silicon. So Intel actually has switch silicon, the Intel Ethernet switch FM6000 series. It's not a switch, it's the switch silicon, and that's the control silicon that goes into the switches. I gotta be real clear on that. These are reference designs. And we support legacy networking, but we also support SDN. It's one of the first switch controllers to actually be able to handle the SDN environment. We can optimize it for flexibility or scale. So we can balance that out, and I'll explain that in another slide. And it still provides that low latency performance that the switch series is known for across the industry. It's known for its ultra low latency on switching capabilities. As far as the technology that allows us to do this, refer to it as Intel FlexPipe technology. It allows us to program and bring in new standards and modify the standards, or the modified standards, into the switch, and be able to run them through the FlexPipe and provide functionality into the network. So we have the ability to do NVGRE as a gateway. We can provide additional offloads. We have the ability to look at different aspects of the traffic and take action on it. So it's not limited to whatever version of the standard we built that was available while we built the silicon. It is something that we can expand out and can be and new standards can be brought in and used in the switch. So one of the things that was announced over this week was gateways. So virtualization gateways. So why are they important? If I have a virtualized network, I have a VSID, I have the traffic going out, that's all being done in the Hyper-V switch. I need some way to be able to talk to non-virtualized network environments. Providing that, Microsoft has the software that's built into R2. You also have the capability, using the switch reference design architecture that we have, of bringing that into the hardware. So you could put this on the top-of-rack switch. You can run the gateway and have the traffic coming up into that switch being put onto the virtual network. There are some benefits on both sides, and either performance, scalability, or redundancy. So this functionality is built into that silicon. And as the standards and as new functionality happens, we're going to be able to add additional capabilities. Example of having standard-based switch management. So being able to control the switch, the physical switch, just like we can do with the virtual switch, with the same tools, with the same standards, SIM-based model like OMI, it allows us to have central control and tie the whole package together. Switch, the reference design will bring in that type of technology, bringing in these common architectures and expand out. So as the standards roll out, we're able to bring them in, and that really will give customers some additional flexibility. This is an open standard or an open platform, so you can run your own applications inside the switch. You're not limited to what the switch vendor has provided. There's going to be a lot more innovation that can happen at the switch level. So looking at it from an end-to-end solution, Windows 2012, now R2, soon, provides a lot of functionality. The virtual machine or the virtual switch, adding additional capabilities in there, adding and enhancing the network virtualization aspects, and being able to control that all from System Center. Be able to control it from that central location, and extending that out into being able to control the network, the physical switches that we're helping bring to market. Adding that additional optimization into the virtual switches to provide full line rate on 10 gig, 40 gig, 100 gig. That's going to take some work. We can do 40, do multiple 10 gig links, but what about 100 gig? Bringing in a single 100 gig link, making sure that traffic is being dispersed in the server. Bringing in new functionality like the network virtualization gateways, but also bringing in additional appliance workloads, load balancers, bringing those into the virtual environment. So now we don't have to deploy hardware appliances in order to add that functionality into a multi-tenant environment. That's costly and limits how fast we can provision the environment. So that's how the whole thing gets tied together, is bringing these from multiple different aspects into a single control model. So with that, I'd like to bring Dhananjay back up, and we can answer questions. We still have, I think, 11 minutes here. And are there any questions?
Thank you.
Yeah.
Thank you, everyone. Thanks, Brian. As we said, network virtualization is deployable today. It's available in Windows Server 2012 and System Center 2012 SP1. And with the enhancements that Intel has made, you get better performance and scale. And in R2, we are doing even further enhancements and bringing in more additional capability where we are putting the network virtualization in the vSwitch. So look for even more further enhancements when 2012 R2 comes on. It revolutionizes network virtualization through multi-tenant clouds with a consistent experience on-premise or off-premise for our customers. And SDN, or software-defined networking, brings back flexibility, control, and automation for you. So with that, thank you for coming. Thanks, Brian. And if you have any questions, we'll be around. There's also other sessions on networking and storage later on in the day, or even at our booth, and feel free to stop by if you have any detailed questions.
Are there any questions?
Any questions? You can step up to the microphones, or
we can give you 10 minutes back. I want to thank you guys for getting up this morning at 8:30, and being here by 8:30. Thank you.